So by the end of this tutorial, you will learn how to perform real-time object detection using state-of-the-art YOLOv10 model and your webcam. If you're a beginner, don't worry, this tutorial will be beginner friendly and we will start everything from scratch. Before we get started, if today is your first time, do me a favor by smashing the subscribe button and also click the like button so that many people will get to see this video and also learn as well. Enough with my self-promotion stuff, let's get right into it. Alright, so the agenda for today is that we'll be performing real-time object detection via our webcam. But before we actually do that, I would love to show you some couple of things. So I'll first teach you how to perform object detection on images using YOLOv10, and then we'll move on to how to access important information from detected objects. So information such as maybe the bounding box, the detection confidence, and also the particular class in which an object is detected. We'll also learn that before we move on to finally the last step where we'll detect object via our webcam. Let's get into it and see the files we'll be using. So over here I have best.png, and this contains some images that will be trying to detect this particular best on. I also have PNG and you can see how it looks. And finally, I have myself, which I'll be using this image to try the model and see how best it detects me. All right, so with the images out of the way, the next thing you have to do is to install some couple of libraries. And today, we are lucky enough, we'll be using only two libraries, Authorities and CV Zone. Okay, so Authorities will help us to leverage the YOLOv10 model, and CV Zone is kind of a wrapper for the OPCV library, which will help us to, we are just basically using it to draw some text, okay, on our detected object. So that's all, but it has other functionalities. If you have been following this channel, you should have known by now. So fast forward, I'll just open my terminal. So terminal, new terminal, and over here I've already created a virtual environment, so I'll just activate it and then install the packages. Okay, so once you get this code from GitHub, because I'll be putting everything on GitHub, just write pip install -r, then you type requirement.txt, and this will go ahead and install all the libraries in the requirement uh, file for you. So see, I've already installed this, so as usual, requirement already satisfied. But for you, you have to make sure you are hooked to the internet because it's going to take some time to install. Okay, so I can clear this off, and the first thing I'll do here is to create my main.py file. Alright, so inside main.py, I'll first go ahead and import Authorities. So from Authorities, I'm going to import YOLO. Also, I'll go ahead and import CV Zone. So just write import CV Zone. Alright, so now to detect objects on an image, it's very simple. So we instantiate a model and we'll call this model YOLO, an instance of a YOLO model. And the particular model we'll be using today is the YOLOv10N. So we just type it inside here. This is the particular model we'll be using. And make sure you are connected to internet, because the first time we run this, it will go ahead and install this particular model in your directory. Okay, so after instantiating this model, we can just see our result is equal to model. And inside here, you put in the image in which you want to perform the detections on. So very simple. We'll start with my image, which is sound.jpg. So that's the image you do. And after this, we can just do results.show, and this will show us our image. My bad, it should be result at 0.show, and this will show us our objects and the detections as well. So I'll quickly run this, and this will take some time. Okay, so over here you can see it's downloading the model and it's done. That's it. You can see the model right here now. So next we are waiting for our detections, and let's see how we can get that as well. And here we go, guys. So you can see it has detected me with an accuracy of 91%, and this is the nano version of YOLOv10. So you can see it's performing quite well on this particular image. So let's go ahead and switch up to another image and see how it will perform on that image as well. So instead of some, I'll switch it to I think let's do car.png. You get access to all these files on the GitHub repository, so the link will be in the description so that you can leverage all these images and everything so that you practice on your own. Waiting, and here we go. So let's see how it performs on this particular cast. So you can see detected a person, a track over there. That's actually not a track, and the confidence is 0.42, so that really shows that, but it's quite high though. I don't know. Okay, so it's performed. This is how it performs on this particular image. It's quite good considering the fact that we are using the nano version of the model and it's doing this great job. I think it's fair enough. Let's try this on the final image, which is birds.png, and see. So birds.png, here we go. Right, so this is how it's detecting these birds. I don't know. It's detecting some with very low confidence, like this particular one, 0.32. Detecting these ones with very high confidence. So YOLOv10 in action here. I think you guys can judge comparing these to other YOLO models, but I think straight off, I can see that this particular model, YOLOv10 model, suffers a lot when detecting smaller objects. It doesn't seem to detect smaller objects so well as compared to the other our previous YOLO model, its predecessors. All right, so this is how you can easily detect objects using YOLO V10. So this brings us to our first objective. We've achieved our first objective. So the next objective is to learn how to access the important information, the bounding box information, the detection confidence, and also the class names. I think those are very important things we need. How to access them so that we can get them in variables and use them. So let me quickly show you that. So I'll comment this. I think then at the down here we can actually write. So we'll be accessing important information from all detected objects, and for that we don't want to show the image again. All we care about is the result. We should comment this one out, and then we can access this result variable and get some output. So first, what I'll be doing is to print whatever is installed in these results, and then from there we can know how we access everything we need. So I'll quickly run this to print that out. Let me clear the terminal and run this once again. Alrighty, and here we go. So when you print this, you can see we are getting a lot of things. This just gives you information about the time it took to run the inference and the image, but we are interested in this particular thing. So first, you can see this is giving us our bounding box information, and this is stored in boxes. Okay, so in order to access bounding box information and confidence information, we should access it from boxes. Our key point is none. We are not doing posts. Max is none. We are not doing segmentation here. And also we get access to the names. So you can see we have the names here. One is a person, a zero is a person, my bad. One is a bicycle, and so on. Then from there, here is the image. So to access the image, we have to be able to get original image, I think. And then lastly, you can also access the shape, the path, and whatsoever. So these are all the outputs we can get from the results variable. So now let's see how we can access this using the Python code. All right, so now I'll comment printing of this result, and then we are going to access the data. So first, let's learn how to access the bounding box. Okay, so for that, we'll say our results at index 0 dot boxes. Okay, result at index 0 dot what boxes, and these boxes come in so many form. You can get it as xy. You can get it as y width and height. You can access any of them, or what I'll do is to print it so that we get a fair idea of how it looks like. Let me just wrap this in a print statement. So here we go. So you can see after accessing the boxes, we can get our class. Okay, we can get our confidence, we can get our data, and all of these are tenses. You can, if you can see, they are all tenses. Okay, So in order to use them, we have to convert them to numpy. Also, now to get our bounding box, you can see the bounding box comes in different variations. You can get what XY width and height. You can get XY width, height, and n. We can get XY, which I prefer. So XY is like uh, normal bounding box we used in OPCV. We have XYXN. So we can choose from any of these. So accessing result of boxes, we can get our class, we can get our confidence, and we can get our bounding box. And that's what we need. Okay, that's the informations we need. So let's try and access them. So this will do boxes dot log xy, and this will give us that particular format. It's a PyTorch tensor, so you can convert it to numpy by writing dot numpy, and we can also convert the values to integer if you want, and you just do it dot as type int. So inside here, instead of mp dot float, you can even do away with numpy and just write. Okay, so this will access it as a numpy array and also give you the type as int. All right, so this is how we can access the bounding box. All right, so let's access the rest of them. Okay, so this is how we can access this key important thing. So we are able to access the confidence, we are able to access the class detected, we are also able to access the bounding box. But bear in mind that this class detected is not going to be an actual name, it's going to be an integer. So later on, when we are learning about how to get objects detected in our live webcam, we are going to use that particular value, integer value, to access the class name. But earlier when I printed it, you saw the class names, and you know how we can access those ones as well. All right, so this is exactly how you can access those things. You just have to print them and you can get all of them. Okay, all right, so that's exactly how it is. So I'll just comment it out. You guys can run them as well, and that's going to work. We'll move on to the final part, and this part is what all of you are waiting for: how to do object detection with YOLOv10 via your live webcam. So let's quickly do that. Okay, so let me give space here, accessing item. Then finally we are going to do live webcam. So I'll just do live webcam, and that's it. So for that, we need to still import these two things. We need to instantiate our model, and then I'll just comment this one out. So the first thing is to access our webcam. So to access our webcam, we need to import OPCV. And once you've installed Ultralytics, OPCV by default gets installed. So you can just import CV2. And after importing CV2, you can now access your webcam. So lookup is equal to CV2.video capture. So inside here, you give it your camera index. If you are using your laptop camera, just put in 0 there. But if you have additional cameras, you can start from 1, 2, so on to get a particular camera you want to work with. For mine, I will be using 1 because I don't want to use my computer webcam. I have a camera attached to the computer, so the index is 1. I'll just put 1 there. Now we can initiate a while loop so that we take this video each frame. So I'll say while true, which is always true. I'm going to get red, which I don't need. Just gives you true or false, either you have your camera open or not. So the next thing is my image, and this is equal to app.read. All right, so now we've grabbed our webcam. The next thing is to show it. So I can just do cv2.imshow, and inside here I can go ahead and show it. I also do cv2.wait key, and I'll put wait key of 1 so that this repeats. So let's test this out. Alright guys, so here I am. You can see me live in the webcam. So now we are able to get our video feed from the webcam. The next step is to feed this video feed through the model and get our important details such as the bounding box, the class detected, and also the class confidence. And then we are good to go. So let's go ahead and do that. Okay, so we'll go ahead and just still write our results. And this is equal to our model we've instantiated at the top, and over here we'll pass in our image. Okay, so inside this result now we can look through it and get our particular information that we need. So I can just say for my particular info in results. So in this particular info, I'm going to get the bounding box, which I'll get from the bounding box. As I showed you earlier, we'll get these informations from it. So I can say my parameters is equal to our info dot boxes. All right, so now I can look through these parameters and get my bounding box, my class detected, and so on. Box in parameters, I think that will be good. So for boxing parameters, we'll go ahead and get our bounding box information x1, y1, x2, y2. So x2, y2 is equal to box dot xy, xy. You remember how we assessed the same thing before coming here, so this shouldn't be a problem. And we are taking it at the first index, okay? So as usual, this is going to return to us a PyTorch tensor, so we have to convert it to NumPy, and also not to forget to change the type to as type int. We don't want float because later on we'll be using OPCV to render some rectangles, and OPCV accepts integer for rendering rectangles, so we have to make sure we convert it to integer values. Now we can also get our confidence. I'll also go ahead and multiply this by 100 because I'll need the confidence to be in percentage, so from 0 to 100, so that I'll know whether it's detecting something by 50%, 40%, and so on. So by default it will just be a floating point value, so 0 point something. So by multiplying it with 100, you are going to convert this based on percentage. Okay, so the next thing to get is the class detected, so I'll just call this class underscore detected, or let's call the class underscore detected number, since this is going to return to us an integer number or just a number. And for this, we have to convert this particular number to integer, so we can just do the same thing. Class detected number is equal to integer value of class detected number, and that's it. So we've converted it to integer. This will return us an integer value. And now we have to go ahead and use this integer value to access the particular class name. So if it has detected a person, is going to be 0. Okay, so we have to use this particular 0 we are getting to access the string person instead of just having 0, which holds no information for us. Okay, so I'll call that class detected name. So this result as in the 0 dot names returns you a dictionary. Okay, it will return to you a dictionary value. So the key 0 is equal to person, the key 1 will be equal to something else. I think it will be bicycle or so. I don't actually know, I've forgotten that. So now we'll access it by the number. So any number detected, we use that particular number to get the detected name. So once we put that particular number as the key, we'll just go ahead and get the name. So class detected number. Okay, so that's how we'll be able to access the particular name detected. Okay, and with this out of the way, we can just go ahead and now render this. So for that, we'll use cv2.rectangle to draw our rectangle on the detected object. And the final step now is to render the text, the name of any detected object you are getting. So for that, we'll also do cvzone to get a nice text. So cvzone dot put text red. So this will just render the particular text and everything will now look great. So let's test this out. All right, here we are. You can see I'm being detected. There are other things being detected. So as usual, I got some couple of things here to use. Here we go. You can see this is a potted plant. It has detected it well. I also have a brush here, toothbrush. Let's see. Will you get this? No, that's not a bat. This is a toothbrush. I got it finally. I'm running this on CPU, so it's kind of lagging. It's a little bit slow. If you have GPU, you can have a lot of speed. Okay, what else do I have? I think I have a button here. Let me try that. Can we detect this? We got it. Got it. This is working. So this YOLOv10 from our live webcam. You see my cell phone perfectly. This is detecting the cell phone as well. Okay, so this is how easy we can use YOLOv8 to run inference from our live webcam using your own IDE. This opens a lot of opportunities for you to use this in your Python code or your projects, build projects right from your IDE. So you can see it's doing the detection so great. Everything looks just good. You guys can just try it out. The code and everything will be on my GitHub. So guys, this is how easy you can perform object detection using YOLOv10 via your webcam. We've covered a lot in this particular tutorial. So the code and everything will be on my GitHub repository. You can leverage it and use it in your own projects. Once again, thanks for watching, and I will see you in another video.